Okay, so far we have learned how to take derivatives of natural log functions, and we've learned how to use our log rules in order to take a derivative of a function involving natural log, and by using our log rules it made the differentiation process a little easier. Okay, so here is another type of problem that we'll be looking at where we have a variable being raised to itself. So here we have y equals x raised to the x power. Okay, so for right now we do not have a derivative rule or a pattern that fits this type of function. So what we're going to have to do is rewrite the problem so that it does look something that we know how to take a derivative for. Okay, so the technique that we can use here is called logarithmic differentiation, where basically we just take the natural log of both sides, and once we use some log properties, you'll see that we will be able to rewrite into something that we are able to take a derivative for. Okay, so first thing we'll do is we're going to go ahead and we're going to take the natural log of both sides. So we get natural log of y equals the natural log of x raised to the x. Okay, and now we can use our log properties where we have a power here, so we can go ahead and rewrite this as natural log of y equals x times the natural log of x, just using our log properties for power to a power. Okay, so now on the left-hand side, when we go to differentiate, we know how to do that. That's just y prime over y. On the right-hand side, now we have a product. We have x times the natural log of x. So when we use the product rule, the derivative of x is just 1 times the natural log of x plus x times the natural log of x, which is 1 over x. Okay, now we want to solve for y prime, so we'll multiply both sides by y, and we get y prime is equal to y times the quantity natural log of x plus x times 1 over x is just 1. Okay, now we want to write our final answer so that we do not have this y left in our problem, so we will plug back in what y was. Y was equal to x raised to the x. So y prime will equal x to the x. Here I'm just going to flip-flop these around so you don't confuse this with natural log of x plus 1. So this is 1 plus natural log of x. Okay, so let's go ahead and look at another example. Here we have y equals x raised to the 3x minus 1. Okay, so same idea. We want to rewrite this problem so that we can use one of our derivative rules. So we'll go ahead and we'll natural log both sides. So natural log of y will equal natural log of x to the 3x minus 1. And now we will use our log properties and bring this exponent down. So natural log of y will equal the quantity 3x minus 1 times natural log of x. Make sure you remember to put the parentheses here. And now again on the right hand side we have a product of two functions, so we can use the product rule. So left hand side we just get y prime over y. Right hand side we need the derivative of our first function, which is just 3 times natural log of x plus first function, which is 3x minus 1, times the derivative for natural log of x, which is just 1 over x. Okay, now again I want to solve for y prime. So y prime will equal y times the quantity 3 natural log x plus 3x minus 1 times 1 over x. Alright, so now we'll do some simplifying and we'll replace the y with x raised to the 3x minus 1. So replacing y, we have x to the 3x minus 1. And now inside of here, I'm going to rewrite my first term as natural log of x cubed. I'm going to go ahead and distribute the 1 over x, so that'll give me plus 3 minus 1 over x. Okay, and that would work for a final answer. If you wanted to do any further simplifying, for example, if you wanted to pull this 3 out, you could. But this would be fine for a final answer. Okay, so that's it for this video. In our next video, we'll be looking at how to do implicit differentiation involving natural logs.